Hey there, this is Seth Schaefer from Team Just Cuz Robotics, and these are some of the latest and greatest products that Just Cuz Robotics has developed to make it easier than ever to build your first combat robot and be competitive right out of the gate. Now, these products I will explain more of in this video, and essentially you can treat this as a video user guide for how best to utilize these, how to service them, be able to replace the magnet rings on these motors, and which motor is best for what circumstances, what size weapons, and what speed controller you should use to power them. I'll go over all of that and more in this video, so make sure to stay tuned. And if you like this video, make sure to click like and subscribe for more if you want to see examples of the bots that I've put these bad boys into competing at different events around the country. Now, I cannot stress enough, before I get into the specifics of the motors, absolutely under no circumstances should you test a robot with a spinning weapon while maintaining line of sight with it. You should always have a barrier between you and the robot, or spin it up with a camera pointed at it and not be in the room if you really don't want to build a test box. But the best way is always to build an actual test box meant for this purpose. I have several videos, and I'll link down below to a couple of them on how to build a test box. I include a free bill of materials, which is a list of all the stuff you need to buy to build one yourself. You can go to a Home Depot and have them cut materials to size for you most of the time. And even if they won't do that, you can just buy 2 foot by 2 foot blocks of wood and, bolt them together to make a 2 foot cube test box really easily. And it'll cost somewhere in the range of like $50 to maybe $80, depending on if you want to add stuff to it. Of course, it can get more expensive. You want to add lighting and paint and stuff, but really it's not that expensive, and it's a hell of a lot cheaper than a hospital trip. So please be safe, everybody, when building and testing your bots. So first things first, let's talk about brushless motors in general, and I'll talk about what the differences are between a standard brushless motor and the JCR series, which right now only has one entry, which is this JCR-4935. So the 4935 denotes the can size of this motor, in other words, how large the whole motor is. So it's 49 millimeters in diameter by 35 millimeters tall from this face to this face. There are kind of two different standard numbering systems that different brushless motor companies use. Sometimes they go by the can size like this, and other times they go by the stator size. So this, for example, is a 2814 by a company called Cobra, and it is a 28 millimeter by 14 millimeter stator, but the actual can size of this motor is more like 35 millimeter diameter by 36 millimeters long. So you can see it's about the same length as the 4935, but it's obviously a much smaller diameter. This Cobra motor is what I used to use as the weapon motor on my vertical spinner bot division in versions like 2 and 3 of it, but I have now switched to using this hub motor, and I'll talk about why in a little bit. Now, how are the brushless motors built and how do they work? I won't go into too many of the specifics of how they work, but basically there are only two parts to a brushless motor. You've got the stator, which is static and does not move, and then you've got the rotor, which rotates, and that does spin. So in this case, the shaft of this motor spins with the bell, which is outside of it, which is why this is what's called an outrunner brushless motor, as opposed to an inrunner where the shaft spins with the inside and the outside is stationary. So this is what the inside of that motor looks like. These are all of the stator coils, and then you've got a bearing and a bearing. And this is already a pretty large motor for a 3-pound combat robot. This is what the stator on the 4935 looks like. So you've got an absolutely massive shaft, massive bearings, an even larger bearing actually on this side, and the rotor comes with epoxy holding all of the magnets together. So under high stress and impacts, the magnets will not shatter, or at least a lot less likely to, which is not something you'll find on almost any off-the-shelf motor, especially not ones that are, this size. And on top of that, it's got a hardened alloy steel shaft, which is 8 millimeters in diameter, which again, for a 3-pound robot is absolutely massive. And you can see all this blue putty there, that's actually balancing putty. So these are actually balanced both before and after the magnets are epoxied to make sure they spin nice and smooth. And the motor goes together like that. And then a large bolt on the bottom just prevents this from being able to be pulled apart like so in the middle of a fight. Now obviously the 5536 RDY-5536 motor is a little different. This motor is a style of motor which is sometimes called a hub motor, which is a kind of specific term within combat robotics where basically the outside of the motor spins, but the inside is completely stationary on both sides. So this blue portion stays completely still while the outside spins. So when the motor's powered, this orange part is all that rotates. And you can see these absolutely gigantic bearings taking all the force of a weapon hit so that the magnets don't experience almost any of that load, because the shaft isn't connected to the rotor at all in this case, with what's known as a dead shaft, as opposed to a motor like this where the shaft spins with the motor bell, which is known as a live shaft. So dead shaft systems tend to be a lot more durable and are better suited for a combat robot. But when you have, something this big, it can still be pretty damn durable. And there are some extra tips and tricks that I have included on the product page for this motor that show how to get the best performance out of it and extend the life of the motor, even though it does have a live shaft setup. Now, it's a little bit more tricky to pull this motor apart, but I will show that process later in this video. But you might be wondering, what exactly the difference is between these if they're about the same physical size. Well, like I said, there are two different numbering systems different companies use to describe a motor. The stator size is more useful when you're trying to compare basically how much power you can get out of the motor, whereas the can size I find is more helpful for designing a robot, because you can actually say, oh, if I design a cylinder that is, 55 by 36 millimeters, it's the size of this motor. Whereas if you just are told the stator size, you have no idea what the physical dimensions of the motor actually are. So, for instance, this motor, the actual stator coils inside of it are pretty similar to the 2814 Cobra motor that I showed earlier. It's not based on this motor exactly, and the internals are from a completely different company, and it's completely different construction and everything, but the physical size of just the coils are about the same as this, just a tiny bit shorter. So this is about a 28 by 12 millimeter stator as opposed to a 28 by 14. The JCR-4935 has an absolutely gigantic 40 millimeter by 12 millimeter stator. So it's a much, much more powerful peak performance from this motor, and it'll also operate at higher voltages without getting super hot, unlike this one, which does tend to heat up, but the outside of it's kind of a big heat sink, so it doesn't matter too much anyway. So let's talk about basically what types of robots you would want to use these motors for and how best to attach your weapons to them. So for the 4935, it's pretty simple. On the top of the motor, there are 4 huge M5 threaded holes, which are way, way bigger than you'd find on any other motor. And this top plate of the motor is 5 millimeters thick solid aluminum. So you've got a lot of thread engagement on here. That by itself is enough to support most 3-pound robot spinners. But as Jameson Go, the BattleBots giant nut winner with saw blaze, has said, putting screws in shear is bad. Friends don't let friends put screws in shear is what he says. And in shear basically means you don't usually want to be twisting against your screws. You usually want them in tension, which would be like trying to pull them out, is the way that they're kind of designed to be used. So to prevent shear loads from being on these screws, there's also 6 millimeter dowel pin holes. And when you buy this motor, it'll come with a bag of hardware like this, which actually includes a bunch of 6 millimeter dowel pins. So what you would do is you'd press these pins into your weapon, and then those would slide into the pin holes on the top of the motor, and then you'd use an additional 4 M5 bolts to clamp the weapon down. So the pins are the only thing preventing it from twisting separately from the motor, and they take all of that shear load. But the screws are still loaded in tension the way they're designed to be, so that the blade doesn't get, ripped off if a vertical spinner hits your horizontal spinning blade or whatever. So this motor is really best suited for putting a blade on top of or underneath your bot, so for overcutters and undercutters.
This shit is not spinning either. What is happening? We might just have a mini bot brawl.
Yeah, going at full blast are both mini bots.
Horizontal spinners almost exclusively will be best suited with this motor because, the top of it spins and the shaft spins, and it's got mounting faces on the top. Whereas this motor instead, this has a clamp ring, so this like thin metal piece here actually comes off with 6 M4 screws. So you'd pull that off, you'd slot a blade into it, and then you'd put the clamp ring over that and tighten those screws, and it clamps the blade dead center. So this is great for if you want your blade in the middle. So for either a mid-cutter horizontal spinner like a Tombstone, or you could do it for pretty much any kind of vertical spinner as well with just a single disc blade. It's not the best if you want to try and do a drum spinner, because the blade is really meant to be kind of a thin blade in the middle that's like a 1/4 inch wide or so. 1/4 inch blades will be exactly centered in this, and like 6 millimeters thick will be pretty much perfect as well. But if your blade is thinner than that, you can add spacers, and if your blade is thicker, you just basically need longer clamp ring screws than the I think 10 millimeter long ones that this comes with, and that will allow you to put pretty much any thickness weapon up to about, you know, here before you can't even mount it to your robot anymore. Also, like I said, the amount of power you can get out of this motor is greater, and generally horizontal spinners have larger diameters, so this is suited for a larger diameter weapon, whereas this is suited for a smaller diameter weapon. So if you're running these on like a 3-cell battery, you could probably run up to like a 9 or even a 10-inch blade on this, like I did on Subtraction, the robot that I kind of built this motor for. On Division, with this motor, I ran a 4-cell battery, so it's a higher voltage, so it spun faster. And that I would use a 6-inch blade as kind of the maximum on 4-cell. With a 3-cell, you could probably go a bit bigger with this. And of course, at higher voltages, the diameters of your weapons should get smaller because the tip speed increases with the diameter of your weapon. And as that tip speed gets higher and higher, the amount of power required to keep your weapon spinning goes up by the cube of speed because of aerodynamic drag. It's a bit complicated, but basically, if you double the tip speed of your weapon, it requires 8 times as much power to keep the weapon spinning. So you really don't want to go much past those limits I talked about unless you really know what you're doing. However, both of these motors, even though they do have different size stators, if you use them the ways that I've described, you can probably use the same speed controller with them. And I've actually developed a speed controller specifically for this purpose. So this is the Pariah 70 amp speed controller. Well, when I say I developed this, I didn't design the hardware of this, but I am getting these made with a custom firmware that I set all the settings specifically to run either of these motors with the best possible performance. You can buy this on my website right now, just like those 2 motors. And it comes pre-programmed to run either of them. And you can also buy an $8 USB programmer with me to change the settings on this. And you can modify them to your heart's content to get the absolute peak performance you want, or to enable bidirectional control. So out of the box, it'll just spin one direction, but you could have it so that it spins both directions and all sorts of stuff like that. I'll definitely make a future video where I talk about AM32 more and how to do those programming and explain what some of the settings mean, but I haven't had time to get around to that just yet. So make sure to subscribe and click the bell icon to get notified when that video comes out. All right, so I've gone over what the motors are and what they do. Now let's talk about servicing them. So in the unfortunate and unlikely event that you do somehow break a magnet on these motors, which is by far the easiest part of a motor to damage generally, even though both of them have battle-hardened epoxied magnet rings, you can actually just buy a replacement magnet ring from me, and that is about half the price of replacing the whole motor. And since that's much more likely to be the part of the motor that fails, it's because I know that these motors are relatively expensive, I wanted you to be able to, you know, keep using them without having to pay full price for a whole second motor, as a way of kind of bringing the cost to use it down, at least over time. So let's go down into my basement shop and take a look at what it takes to replace the magnet rings on both of these motors, and you can kind of get to see the insides of the motors in a bit more detail, especially the hub motor. Now, I sell replacement magnet rings for this, and so I want to show you guys what the inside of the motor looks like, and I can also show the process that's needed to take it apart in order to replace the magnet ring, or if you wanted to service the motor and to check for any other kind of damage that might have happened to it. So let's start with that process. If you buy a replacement magnet ring from me, it'll come looking just like this, so you will have to remove the clamp ring and save all the clamp ring screws, or buy new ones if for some reason they got mangled or lost. So this piece isn't going to come with a magnet or a magnet ring replacement, and you can reuse every other part of the motor, so just make sure you hold on to every piece except for this if this is the only part that gets damaged. So to start off with, we're going to unbolt the motor from our frame, as you would expect, but we need to basically take out this center screw and this center screw, which are Loctited from factory, and you need a 2.5mm hex wrench to do that, same as for the outside screws. And it can be really hard to hold this because obviously it wants to turn. So what I recommend is you put 2 screws in. Again, make absolutely certain you don't put them in too far because you can damage the coils, but just insert 2 screws part way. All right, so we've got 2 screws sticking out of the motor. We can hold on to those as our way of counterbalancing it. And now we've got enough torque to twist off that center screw. Should be the exact same length as the others, but we'll put it aside for now. And then we're gonna just do the same exact thing with this one. Cool. Now you are probably going to need an arbor press to get this apart. Kind of need to basically try and yank it apart. Ideally we want to pull this part off, but again we need something to grab onto. Oh, that actually came apart way more easily than I thought it would. So yeah, that is pretty much it. You just yank it apart once you've got the screws in there. So now you can kind of see what the inside of the motor looks like. You've got the stator coils, they've got a bit of epoxy on them, not too much because it can hurt the thermal performance. If I yank on this side, maybe that one will be hard to pull out. Yeah, I might need a press, an arbor press, to pull this part out, but that's okay. Let's bring this over to the press. Alright, so to try and press this out, first I'm going to install this screw so it sits up past that top surface so I can press down on this. Just get that a few threads in, and then remove these because they're in the way. Alright, next we just need to get only the orange portion and not the bearing on this wood. Get that pressed most of the way out already. There we go. And that is it. So it's taken apart. And as you can see, this blue piece is like a separate part. It's meant to come apart from the shaft. So the shaft is just that blue center thing. That's all 7075 aluminum. These blue inner hubs are also 7075 aluminum. Outside is all machined 7075 aluminum, just anodized a different color. And then you've got your steel flux ring with the magnets and their magnet epoxy in there. And yeah, the shaft has a little square pocket that it goes into to prevent the two sides from rotating separate from each other. So that makes sure that your screw holes are all aligned. So you just have to make sure you get that seated fully all the way when you put it back together. And then you should be good to go. And I would recommend you could just press the whole thing back together when you swap the magnet ring, but I would maybe recommend adding a little bit of green Loctite, which is a retaining compound, to the inside of the bearing races when you put it back together. And then if you want to take it apart again, you might have to heat it up to break down that. But yeah, and it doesn't matter. It does not matter which way the stator goes into it necessarily, but it, I think, makes your life easier to do it with the wires coming out this side, because that way your blade comes off on this side. You don't have to thread it through the wires or anything. Alright, now let's show the process for reassembling it. So I actually pushed back in really easily on that side. Alrighty, so we got the other half with the other bearing. And again, we want to make sure we align the screw holes properly, because they can go 90 degrees apart from each other if you're not careful. Come on, see, that's rotating separate from the other side right now. There, now those squares are locked together, so now you can see it turns with the other side. And you gotta make sure, because it's a rectangular hole pattern, so you've got that wire hole and this wire hole lined up with each other on the top. Not 90 degrees apart. And that's pretty much it, other than putting those two center screws back in to reassemble the motor. So once again, we're going to put those screws in part way, and I'm going to add a little bit of blue Loctite to my center screw. Perfect. Now we've got our reassembled motor ready to rock and roll. And then once again, you can put your blade on, followed by your clamp ring, followed by all 6 of those clamping screws to get your weapon assembly back together. Alrighty, I've just showed how to do a magnet replacement on the hub motor, so why don't we take a look at the much easier process for replacing the magnet ring on the 4935 motor. Now this one is one of the prototypes, which is a different version. You can see the shaft looks completely different on the top end because the flange shaft is the upgrade that I made to make this way more durable than it was in Subtraction version 1. But all you need is a 3mm hex wrench, and you might need a press, but it shouldn't be too difficult. So to start off with, get a good grip on this And we just need to take off one screw from the bottom. Whoops. Thankfully my motor caught it. And then, this might take more force than that, but should be able to pretty much just yank this apart. Take the new magnet ring, slap it in. Careful not to pinch your fingers because those magnets are extremely strong. And then again, you'll want to apply some Loctite to this. And once you get that screw in with Loctite, just tighten it back up. So now we've got what looks like a brand new 4935 motor, even though it has a used and battle-worn stator and bearings inside. All right, I've got one more little announcement to make, and that is on behalf of John O'Brien, who is helping to host a combat robot event, the first that his makerspace, Revolution Makerspace, will be hosting. He wanted me to say that as part of the upcoming Watch City Steampunk Festival in Waltham, Massachusetts, which is pretty close to me, they will be hosting an Antweight robot tournament called Robot Rumpus 2024. Many robots will enter and only some will leave, at least in one piece. Come join in the fun on May 11th. The Steampunk Festival is always a good time, and robot combat makes it even better. If you're interested in participating as a contestant, I think I'm a bit late making this announcement and it might be full, but there are 16 Antweights signed up, and I will link the event details down below, as well as details to find out about the Revolution Makerspace and the Steampunk Festival itself. The reason I'm making an announcement about this particular event is because the organizer reached out to me about using my arena design as the arena to host this event. So if you want to build your own Antweight arena and host your own combat robot events, I'll also link down below to the free Antweight arena plans that I have uploaded to my website. Alrighty, I think that just about covers everything I wanted to talk about for this video. Let me know in the comments down below if you enjoyed this type of video, if you'd like to see more videos like this that cover, how to use some of my other products in the best way possible and the differences between them. And also comment below if you've got any questions about things I didn't address directly in this video. As always, like this video if you liked it, and make sure to subscribe and click the bell icon for more if you loved it. And as always, thank you so much for watching.